Here is a nice trig equation for you to try. It comes from a non-calculator STEP exam. Here is the full question if you're curious. If you want to know more about STEP, there'll be a link in the description to their website. And if you want to give this question a go yourself without any help, pause the video now. Okay, the first thing this question asks you to do is to prove this identity. So it says prove from the identity for cosine of A plus or minus B that cosine of A cosine of 3A is equivalent to a half cosine of 4A plus cosine of 2A. Here is the sum and difference formula if you are struggling to recall that. And I really encourage you to pause the video here if you didn't already and try to prove this identity yourself. It has a really nice, neat solution. Now to prove this identity, you need to notice something about cosine of 4A and cosine of 2A. Now how can we relate those two expressions or those two terms to this identity? So how can we write, what is another way to write cosine of 4A? Okay, so you need to notice here that you can write cosine of 4A as cosine of A plus 3A. And then we can use that identity to expand this out to cosine of A cosine of 3A, subtract sine of A sine of 3A. Okay, now how can we write cosine of 2A? Maybe take a hint from that first expression we found. Cosine of 2A we can write as cosine of 3A subtract A. This is equivalent, again using that identity, to cosine of A cosine of 3A plus sine of A sine of 3A. Now this is really nice because we can now add these two expressions. So we get cosine of 4A plus cosine of 2A. And notice these terms, including the sine function, they cancel out. So we get 2 cosine of A cosine of 3A. We're almost at this identity. If we just divide by 2, we get a half cosine of 4A plus cosine of 2A is equivalent to cosine of A cosine of 3A. So there you go. No need for an identity crisis today. Alright, now we can get on to solving the equation. And we have 4 cosine x cosine 2x cosine 3x equals 1. We can use that identity we just found and substitute that for cosine of x cosine of 3x. So we have 4 cosine of 2x multiplied by a half cosine of 4x plus cosine of 2x equals 1. And then divide 4 by 2, so we get this expression. And now notice that we have two terms with cosine of 2x. What's the odd one out? Is this cosine of 4x. So we want to somehow write the cosine of 4x in terms of cosine 2x. How can we do that? We can use a double angle formula. So the double angle formula we're going to use is cosine of 2 theta is equivalent to 2 cosine squared theta take 1. So if we have cosine of 4x, this is equivalent to 2 cosine squared 2x take 1. So substitute that in for cosine of 4x here. Okay, substitute that in and then expand the brackets. So we have everything in terms of cosine of 2x, and this turns out to be a nice cubic equation which we can solve. Okay, so we have this cubic equation here. Let's let cosine of 2x equals m just to make it look a little bit neater. So we have this cubic, 4m cubed plus 2m squared take 2m take 1 equals 0. And now we need a method to factorize this cubic. Okay, the first suggestion I have here is to think practically. This being a non-calculator exam set to a certain level, you can probably expect that the angles we get out of this will give us some nice, exact values for these cosine functions, right? So likely one of the roots will be in this list. So either a half, 1 on root 2, or root 3 on 2, related to the angles pi on 3, pi on 4, and pi on 6. You can also think about the rational roots test. So maybe that's overkill, but if you haven't seen the rational roots test before, this says that all rational roots will be of the form p on q, where p is a factor of the constant and q is a factor of the leading coefficient. So for example, well, we have -1 here. The only factors of -1 are -1 and 1, and factors of 4 are 1, 2, and 4. So an example of p on q would be 1 on 2, right? So that's a factor of the constant and a factor of 4. Gives you one of the possible rational roots. So if there is a rational root, the rational roots test says that that must be in that list of x equals p on q. So we could try, for example, x equals a half. So that both matches with our practical thinking that it's likely an exact value of the cosine function, and it obeys the rational roots test. So if we plug in x equals a half, we notice we get -1 out from that function. So that is not a root. Now when you're trying roots for a cubic, it makes sense to try both the positive and the negative. So next we could try x equals -1/2, And we do notice, in fact, that is a solution to that equation. So we have a factor there. So now we can find the quadratic, the remainder of that division when we divide by m plus a half. And we know the final term must be negative 2 in order to get this constant negative 1. And the coefficient of m squared must be 4 to give us 4m cubed. Then we can solve for b by inspection. I have a video on polynomial division, which is what we're doing here if you want to see this process in more detail, so check that out. So by inspection, we notice that the coefficients of m will be b on 2 and negative 2, and they must equal negative 2, which is the coefficient of m in our original equation. So then we can say b on 2 take 2 equals negative 2, which implies b equals 0, and then we've factored our cubic. So we get m plus a half multiplied by 4m squared take 2 equals 0. Now if you're not happy with that approach, there is another method you can try. It's called grouping. This is just, sometimes hard to see. So looking at this cubic, grouping asks you to look for factors that you can factor out of pairs of terms to find a common factor. So if we look at these two pairs of terms, can you see something you can factor out to give you a common factor? So yeah, again, this is just kind of something you have to do by inspection. And you might notice that if you factor out 2m squared from the first two terms and negative 1 from the second two terms, you get 2m plus 1 as a common factor. Again, this is just kind of something you have to see. It's not always so easy. So then this factors to 2m squared take 1 multiplied by 2m plus 1 equals 0. And you might notice it looks different to this factorization, but it gives you the same solutions. In both cases, you get the solutions for m of negative a half and plus or minus 1 and root 2. Okay, so as we let cosine of 2x equals m, then cosine of 2x equals negative a half and plus or minus 1 and root 2. And our original range was for x, so if we multiply through by 2, our range for 2x is 0 to 2 pi. So now we can look at our unit circle to finish this off. We have a solution at negative a half on the x-coordinate, so that will give us a solution in the second quadrant where x equals negative half, and in the third quadrant we have a solution at positive 1 and root 2 in the first quadrant and the fourth quadrant, and we have solutions for negative 1 and root 2 in the second and the third quadrants. So we're looking for the angle of rotation to those 6 points, and to find those angles we just need to find the angles to the point in the first quadrant and the second quadrant. Okay, so we're looking for those two, and here you need to recall your exact values for the trig functions. This is something you generally learn to memorize. So if cosine of theta equals a half, that means theta equals pi and 3. So the angle in the second quadrant there is pi and 3. The angle in the first quadrant, that's when cosine of theta equals 1 and root 2. That means theta equals pi and 4. So we have those two angles, and now we can go ahead and find all of the solutions. So therefore 2x, if we're looking for the angle of rotation to the point in the second quadrant here, that's going to be pi take pi and 3. Then this point will be pi plus pi and 3. Then this point over here is just pi and 4. Then the point in the fourth quadrant is 2 pi take pi and 4. And the other 2 points in the second and third quadrants are pi take pi and 4 and pi plus pi and 4. So we have the solutions for 2x. We just need to simplify those fractions and divide by 2, and we get solutions for x of pi and 8, pi and 3, 3 pi and 8, 5 pi and 8, 2 pi and 3, and 7 pi and 8 for our range of 0 to pi. Lovely. Hope you liked that problem. Please leave a like if you did, subscribe if you want to see more content, and I'll see you in the next one. Bye for now.